All right, so here we are, March 11th, and today we're going to talk about mechanical, biomedical engineering. And so to get us started, I have just a little slideshow presentation to share with you just on the, like an overview of mechanical engineering and some of the different sub-disciplines of it and that. And then we have two guest speakers who will be joining us. One will address the robotics portion of mechanical engineering, and he is a Cabrillo alum. And one will be addressing the biomedical aspect of mechanical engineering. And she also is I know she's not a Cabrillo alum, but she has agreed to come and speak with us about it. So I think they're going to be great dynamic speakers, and I hope that you'll come up with some really good questions for them. And just to let you know, Joanne and I have been taking these interview videos and extracting them to show in future classes. And so if you have these great questions also, that also helps future students, not just yourselves, but students that come later that may see these videos. So please do not hesitate to ask questions. I think it really enriches the conversation that we have as a class, as well as now think about future students might be seeing some of these videos and hearing those questions and having the same questions, but they won't have the opportunity to ask. So this enables them to get the answers that they may also have questions to. So I want you to think about that. And then after that, we'll take a break, at which point you can, again, gather these materials, and then we'll do a project. So that's the plan for today. Okay, so first thing I wanted to do was talk about mechanical engineering. And so I'm sharing my slides, and here's the first one. And I think, mechanical engineering is one of those that's really the broadest of all of our engineering disciplines. And I think all of you know, on a baseline level, what mechanical engineering is for sure. And then you probably know a lot of the major disciplines, but it has a lot of smaller subsets of disciplines within it. And it actually also happens to be very integrative of some of the other disciplines as well. So to give you an example, as a mechanical engineer, you need to know a little bit about electrical engineering. You need to know a little bit about civil engineering. So it encompasses some of these other ones, not to the level of detail that you would see in one of those fields, but a little of each. Mechanical engineers tend to be those people who are kind of jack of all trades. And the work that they do ranges from the bottom of the ocean to the far reaches of outer space. So, really, it's such a wide range of things that you could be working on as a mechanical engineer. And like I said, it's one of the broader engineering disciplines, and gears are often associated with mechanical engineering. So that's why I've got this here. Did someone have a question?
Yeah, I have a quick question for you. I noticed that there's 35,000 graduates in mechanical engineering. It's the most graduates of all the fields.
Yeah.
Is that making an impacted field and thus harder to get a job if you go that route, or does that make it because that's just the highest demand?
That's a really, really good question. And I think you're taking it out of that ASEE paper that you guys were asked to read for one of your homework assignments.
Correct.
So I would say that it's kind of like the chicken and the egg, which came first, right? So you've got 35,000 mechanical engineers graduating. Well, they wouldn't be pumping them all out if there weren't jobs for them all, right? So you wouldn't study that if you're not going to get a job in it. Know that, 35,000 come out. Not necessarily all of them go into jobs in mechanical engineering. Some of them go further on into graduate school, maybe explore other disciplines, and some of them go to specialize in a field of mechanical engineering. So given that it's so broad, it provides a really great basis and a jumping point into a lot of different fields. I can't really speak to, is every single person coming out and getting a job? But if they weren't, there wouldn't be such a demand for it, and people wouldn't be going to school. Like you hear, out there that, all these people, there are no jobs for attorneys this year. So you know what happens? People don't go to law school. They hear that and they stop going to law school. We don't see that trend with mechanical engineering. So I think one of the cool things about it is kind of like I said, you know a little bit of everything. And so you can really apply yourself in different positions really easily too. Yeah, good question. Okay, any other questions before I move on? Okay, so mechanical engineers work a lot with what's called simple machines. And this is just a little illustration of a bicycle that's a simple machine. But the point of it is that they work with machines, different kinds of machines. They could be powered machines, they could be unpowered machines, alternate power machines. You'll find mechanical engineers working in all sorts of machines. Things that move is kind of where mechanical engineers find themselves. So I just thought this was a nice little illustration of that to give you an idea, just to set up the stage for what we're going to look at next. What do mechanical engineers do? Well, they combine a lot of creativity, knowledge, and tools to bring ideas into reality. And these ideas can affect us in our daily lives, basically. And they're always trying to enhance the lives of others. And you'll see this with things like robotic prostheses. Mechanical engineers have a big role to play in trying to find ways to help people. And that's just one example of that. So let's see. This is kind of a schematic that shows, what goes into becoming a mechanical engineer. So here's some classes that are really critical. And see here, this is a civil engineering thing. Material science engineers, you learned about that last year, know a lot about materials. Mechanical engineers know a little about materials too. Mechanics, kinematics, and thermodynamics find themselves actually in most engineering disciplines. You need to know mechanics and thermodynamics a little bit. Kinematics is really more for the mechanical engineers as well. And then computer-aided engineering, this is CADing, drawing. A lot of mechanical engineers do a lot of CADing. And then this is sort of the business side of things. And you put all of that into mechanical engineering, and then you have this list of things that comes out of that. So you could apply yourself with a mechanical engineering degree to any of these fields and more. And I think in the next slide, I have a whole bunch of fields listed, actually. So this is just an overview. The traditional mechanical engineering fields that you probably may have heard of was like HVAC, heating and cooling. A lot of mechanical engineers went into that. My dad actually was a mechanical engineer, and he worked for a big grocery food chain. He worked in their headquarters, and he was all about the building maintenance of all of that. So like if a refrigerator went down, in a store, obviously it would work its way up the chain to where it got to him if necessary, like if it was a larger issue. And he would be doing with a lot of contracts with vendors, providers of services for HVAC and lighting and all sorts of anything that was running the building. So he needed to know a little bit about electrical engineering. He needed to know a little bit about heating and cooling, and he was kind of bringing it all together in his position, and a little bit of business working with vendors. So that's like a nice example of that. So here's a more thorough list of all the different fields that you can find mechanical engineers in. And I'm not going to talk about all of these because some of them you looked at in your obscure engineering disciplines talk. But the big ones that you may want to consider, aerospace, this is specifically to space travel and also aviation industries. And there's, with this mission to Mars, there's a lot of opportunities in aerospace at the moment, actually. And I think one of our speakers that was recorded talked about the mission to Mars. So that's a big field right now. Automotive is, one of the traditional fields in mechanical engineering. So it's been around a long time. So I think you guys kind of know a lot about that. Here's another emerging field, autonomous systems. Does anyone know what that means when I say autonomous systems?
Those are things that work on their own, like an autonomous vehicle.
Exactly. And so you guys have had the opportunity to see the development of autonomous vehicles, the pitfalls, the growth, all of that, because it's really come about in the last 10 years, really, it's been growing. But to give you an example, my husband studied mechanical engineering, and his master's project was on designing autonomous systems in vehicles, and that was in 1995 and 1996. So he was at the forefront of the research being done at the University of Michigan for this. And now you're seeing it in 2021 as mainstream, not mainstream, I guess. We haven't really gotten there yet, but really emerging into a place where we can maybe go mainstream with it. So that kind of gives you an idea of how far we've come, how long ideas take to reach the mass market, and that there is actually a lot of opportunity in this area right now. We'll hear more about biomechanical, so I don't want to talk too much about that. Composites, this you learned about with material science most likely, but it finds its way into a lot of these different areas actually as we explore materials and new materials and composites and find really great ways to apply them. Like I just went shopping for a bicycle and found out that the carbon version of the bicycle that I really loved was $3,500, and the aluminum version was less than half that. And I was like, wow. And that's a composite. So, they're making bikes lighter and lighter with these materials, which, if you want to go fast and far, is really useful to you. All right, CAD, let's see, design, we've talked a lot about. Was there anything else? Mechatronics. So mechatronics is also a newer major in mechanical engineering, and there are a handful of programs across the country that now offer this degree, and it combines mechanical engineering with electrical engineering. So it's kind of like a dual major, and they call it Mechatronics. And this is actually really useful if you want to work in robotics. That's where you'll find that there's a lot of application for mechatronics. And I have robotics listed separately as well, but this is also a great degree to consider if that's your interest. And you can actually ask Aaron more about this degree. I think that's the degree he got. Nanotechnology, that's an up and coming, or actually not up and coming. That's a field that's also growing rapidly too, as we're trying to make things smaller for the same applications. And, like you can just look at the history of a cell phone. What was it, 1993, I was sitting in a car with a friend of mine who had a car phone. I know most of you would have no idea what this is because they went away really quickly, but it was a phone that sat in the car, and it was kind of the size of, your laptop, basically. And look at our phones today, right? So we are able to take our expertise and knowledge and start to make things smaller and smaller and smaller. And nanotechnology means 10 to the minus 9th scale. So we've gotten them super, super small. This is great for in terms of resources. When we make things smaller, we use less resources, but it also increases the number of applications where this could be used specifically in the medical industry as well. Is there another question? I heard a mic come on.
Well, Ulysses suggested Roombas, and I think he might have been talking about the autonomous. I'm not quite sure.
Well, that's both autonomous and smaller, right? We've taken this huge vacuum cleaner. I don't know if you guys know what those vacuum cleaners used to look like, but the upright I had, the first Hoover ever, was huge. And now you've got this tiny little Roomba, and it's autonomous, right? You set up, it's really cool how you set up the boundaries, and then it's tiny and it does the job. That's a great example of combining some of the things I've been talking about here. Yeah, and robotics. It's a little robot. So really good stuff there, and lots of opportunities in this field. Let's see, what else do I want to say? So I've actually accidentally talked about my slides a little bit that are coming up ahead. Here's some very simple mechanical engineering or devices that were created by mechanical engineers a long time ago. I don't even know if you can find any of these. These are super old. But now you can see you can take a console like this that you had to go to somewhere and play in, and you can still go and play in these things. But think of like how small they've gotten, right? Where they're now all in our homes. So things like that. All right, and nobody even has one of these anymore. Now we just have digital music. It's amazing. Okay, but here's where I wanted to go. So these are the major fields of mechanical engineering that has been kind of historically the ones that have been the larger, actually, let me say the larger subfields of mechanical engineering. And I think you're all very familiar with automobile, HVAC, manufacturing. This is the aerospace. Energy is a big one in mechanical engineering. There's a lot of mechanical engineers involved in like the development of solar panels, things like that. As well as in the past, extraction of oil and things like that as well. And the provision of those utilities as well. And then biomechanical, this is the use of mechanical engineering combined with biology. And it allows us to create things like prosthetics, even robotic exoskeletons, enabling us to help people with injury or any struggles they're facing, basically. The cool thing about this is that we have recently used the concept of 3D printing. So take that from like your CADing, the computer aided design allows us to create objects in 3D. And then we created a printer that puts a filament in there. And then with that, we've been able to now 3D print organs. And that, I think I have a little video of, and I might have to stop this share to show you that. So let me see if I can get there. Yeah.
Before you get there, do you have a good suggestion for a CAD program? For maybe a beginner, but something that would kind of pull through for the long run as well?
So I teach Engineering 25, which is Autocad. And Autocad is free to educators and students. So if you want to learn CAD in a semester, we go through the basics of that. Actually, there's a couple students in this class that are in my class there. Another one that's used industry-wide is SolidWorks. That's not available for free to me, but there are programs through which you can access it for free. And those would be the two big CAD programs. Now, there's a bunch of online CAD programs that are also free. Things like Tinkercad, which are made for kids to get started working in a CADing program in an environment. It comes with pre-made shapes. So any of those would work. And you could ask Aaron today what he suggests as well. Him being in industry, that would be a good question for him.
Thank you, Preeti.
You're welcome. And I'd love to see you guys in my class in the future. Okay, so I'm going to share this with you. Oh, actually, let me just see who. Aaron's here! So I'm running late. Can I just show one little video? Just one little video. Okay, thanks. So I just thought this was really cool. So I want to share this with you. And it is a 3D heart that is pumping, a 3D printed heart that's pumping. Is there sound? Let me see. There's no sound on it. But basically, this was developed at the University of Minnesota, and this is really for helping people with heart disease, which is one of the leading causes of death in the U.S. It kills more than 600,000 people a year, and this was just published, I think, last month. So, I just stop. How do I stop? Okay. Stop. All right. So I just want to say, that there's this is a really fun field and lots of different opportunities. My last slide had some examples of nanotechnology, composites, and things, and we can come back to it if you have questions on it. But I want to give Aaron the floor. He's here to speak with you all. And so just to give you a little bit about Aaron, he was at Cabrillo College and then got his undergraduate degree in mechatronic engineering from Cal State University, Chico. So definitely ask him about mechatronics. He did a minor in computer engineering and sustainable manufacturing. And he's currently at Omron Robotics and Safety Technologies in Pleasanton, where he works as an application development engineer in the fixed robotics lab. Welcome, Aaron. So great to have you. This is our Engineering 5 Section 1 class.
Thank you, Pretty. Hey, everybody. My name's Aaron. As Pretty mentioned, I work at Omron Robotics and Safety Technology. I'm going to share my screen because I do have a little presentation to give you guys. Okay, can everybody see that okay?
Yeah.
Great. So, as you mentioned, I graduated CSU Chico in 2018 with a mechatronic engineering degree. Chico is one of the few colleges west of the Mississippi with an ABAT accredited engineering degree. Others just combine mechanical, electrical into sort of a overall coursework. So I work as an application engineer on collaborative robots. Collaborative robots are kind of a new thing in the industry. And I'm sorry if there's noise behind me. We have some construction going on down the hall. So collaborative robots are kind of a new, big up and coming thing in the industry. They're for use around people. You don't need as much safety guarding, cages, things like that. I've got one here behind me that I call Timmy. Say hi, Timmy. And some of the other things that we work on, Omron was established May 1933 as a $6.5 billion annual sales company with over 28,000 engineers and employees worldwide. And for anyone that's looking for internships, we do have some things online, so feel free to look at those. Primarily, this company that I work for, Omron is a big company. It actually does health, all kinds of different things, safety. But my building does robotics. We do fixed and mobile robots. Some of our fixed robots are the Quattro and Hornet. The Quattro on the left here is actually one of the world's fastest robots currently. And it's used in many pick and place packaging applications. We've also got some mobile robots from a 60 kilogram all the way up to a 1,500 kilogram payload robot. So this HP 1500 can actually carry around 1,500 kilograms of payload. The robots I work on are collaborative robots, and we kind of do a lot of different manual labor, sort of dull, dirty, dangerous types of jobs, assembly, pick and place, machine tending. Machine tending is actually really a big application right now that people use. Babysitting a CNC machine is not fun. I've done as my first internship was at Fox Racing Factory in summer 2019, and I did babysit a robot. It was boring. So I'm a returning student. I actually have a business background. I came from the business world and decided that I didn't want to do sales anymore. I wanted to get something more technical. And I knew that robotics, machine automation, factory automation was going to be the future. So I decided to go there. Now, when I went to Chico State, I knew the importance of being on a team. If any of you guys are on the Cabrillo Robotics team, and if you're not, I hope that you take a look and join that. I actually founded that club. And I knew the importance of getting on a robotics team or just being on a team in general, because that's how you do projects outside of class. That's how you put your theory to work and practice. And recruiters, they are a lot of times, I mean, grades do count and stuff, but a lot of times they're more interested in what have you done? What have you worked on? Right? What projects can you show me that you used your engineering knowledge and engineering design process to solve a problem? And so the team I joined was the Baja team. I did lead suspension for 2 years, and it wasn't anything related to mechatronics. I did in the last year, I did take and create a data acquisition team for the Baja card. And so we outfitted the car with all kinds of sensors, strain gauges, motion sensors, things like that would allow us to take data and validate our engineering design philosophy, right? So we have an idea, we think it's going to work one way, we put it on the car, we take some data, we analyze the data, and we see, were our calculations correct or were we way off base? And so even though I wasn't on a robotics team at Chico, I found a way to incorporate mechatronics into what I was doing. Here's some pictures of what we do, what we did on Baja. I talk a lot about Baja because it was the most fun I've ever had in my life. Being on a team like this is so important. I cannot stress enough how helpful it is in finding a job in the future. So, as you know, the COVID pandemic is sweeping the world right now. Robots in real life are currently used for disinfection, material transport, room service, things like that. So I just wanted to give you guys a quick example of how these robots are. That's the end of my slideshow, but I have a couple more things I want to show you. Pretty mentioned biomechanics, biomechatronics, or what's commonly known as biomimicry. You guys are interested in that, and I highly recommend you take a look at that. It's actually something that's more offered as a master's degree or a PhD course. But Festo is a company that actually produces solenoids, pneumatic actuators, things like that. But they have a bionics research department that makes some of the things scrolling across the screen now. And this company is probably one of the most amazing companies to work for in the entire world doing bionic mechatronics. I've also got one here, soft robotics, another big up and coming space. And I'm telling you guys some of these things because you're still a few years away from being in the job market. And so what is being thought about right now is just an idea, is going to be reality that you'll be working on in 4, 5, 6 years from now, right? So soft robotics is another area that's really big and up and coming. And for CAD design, I use Solidworks. My whole company uses Solidworks. If you go to a university or a four-year college that uses Solidworks, you often get a free license during your time there, a student license. I got a license through the engineering department at Chico State. I also got a second license through the Baja team at Chico State because they sponsored the Baja team. But other really good options that a lot of people use and a lot of people really like is Autodesk Fusion 360. And I believe there's a free version available for that. If not, there's a student version available. If you give them your Cabrillo email, or if you have a Cabrillo email address, or when you get to university and have a university email address, you can often get student versions of a lot of this more expensive software, SolidWorks included. But Fusion 360 is a very popular one for to start and for hobbyists. And that was kind of quick, so I'll leave it open for questions if you guys have anything that you want to ask me, or if you want to talk about anything specifically, just let me know. Oh, one thing I do want to show you is that, so mechatronics is kind of a really versatile degree, right? We do design, we do hardware, we do software, and we do electrical, right? So sometimes I might be setting up a robot and programming it to do just a little vision job where I, have some commanded motion. Other times I might be setting up applications where I have to design a large fixture, like this one.
Hey, Aaron, do you mind not sharing your screen so we get a bigger view of you and your machine? Okay, great. There, cool. Okay, now we can see it.
Okay. So this is a basically a jig, what I call a jig or a fixture to hold a car fender. The application I'm developing uses the collaborative robot and an orbital sander or buffer, polisher, to buff the car body, right? And so we have this thing that we call CAD to path, where you take a CAD file, import it into the software. You can create robot paths on the surface of this CAD model, and then the robot will be able to follow these contours, right, and polish this surface. So a lot of my day recently has been spent designing hardware, trying to come up with how to make this thing work, figuring out how the application is going to work, what kind of specifications I want the application to perform, etc. So that's what I really like about mechatronics. It's so versatile and varied that you're doing a lot of different things all the time. It's never boring. You never just get stuck doing, software in front of a computer all day. So that's kind of all I got for you guys for now. I'll open it up to questions.
So I'll ask the first question, and then I'll ask the class either to type questions in the chat that I can read, or feel free to unmute themselves. But you mentioned that your company has internships. How would they go about finding more information about the internships?
Good question. So what I recommend is, obviously LinkedIn is a great resource, but if you just go online, search for Omron jobs, you'll get the Omron webpage, job search page, and then you can search by field. I like to search by location. If you want to stay in California, we have, as I mentioned, regions throughout the world. So we have, Omron has offices in Pleasanton and in New Hampshire, Amherst, New Hampshire. But we also have different business units throughout the world, in Chicago, South America, Europe, Asia, Australia, all over the place. So really, it's a great company to work for if you are considering, branching out in the world and going somewhere else. But if I go to the Omron USA website, it allows me to search for jobs in electronics, healthcare, industrial automation. The business unit I work for is the Omron Robotics and Safety Technologies, ORST, Robotics and Safety. And if you click that link, it'll take you to currently 47 jobs open, 44 in the US, 2 in Mexico, and 1 in Canada. And we have a summer intern position open for a software engineer, I see. Mechanical engineering internship. Probably a couple more. Embedded software intern.
So would our students in Engineering 5 qualify for those, or do they need to get some more experience in a summer and a different type of internship before they qualify for those?
I would say they probably should have a certain level of understanding about some of these things. Maybe a entry level, like freshman, sophomore level, four-year classes. The thing about Cabrillo is you guys are so like ahead of the curve, above the average at Cabrillo. With you're learning things that you'll go to, you'll transfer as a junior to your college, or maybe a sophomore if you're in a 5-year degree program. And you'll find that Cabrillo has taught you things that are more advanced than what you're learning in your classes right now, right, when you get to university. So having a level of knowledge at Cabrillo is definitely, now Engineering 5 I know is one of your first courses, so you may not have gotten there yet, but some of you, don't wait, go out online, YouTube University. I call it YouTube University because there's just so much information you can find on YouTube. It really got me through college, helped me out immensely. So take summer classes, don't wait for your normal coursework, and just go out there and teach yourself, right? So there is a certain level that you will want to have. But some of you may have that just from the background, your personal background, doing hobbies. If you like to hack on Arduinos or Raspberry Pis, then embedded software, you might already have the knowledge you need to get that internship. So
cool.
It's never hurts to ask.
There's a couple questions in the chat. First is, how long did it take to design and build the robot that's behind you? And the second one is, what inspired you to go into mechatronics?
So the robot behind me, we don't actually design and build. This is one of the few robots that is designed by another company, and we just offer for sale. But the design process was probably about 3 to 4 years minimum. We're actually we're going through the company right now to redesign this robot. And it's been about a year already, and we don't expect a release until summer 2022. And so a minimum of 2.5 years typically for a design process from scratch to first sale. what inspired me to go into mechatronics was, as I mentioned, I came out of business. I was trying to decide what do I want to do? What kind of degree do I want? That I don't want to do sales anymore. I need a degree that's going to be, you know, a well-paid degree, something that I can take a lot of different places and use at different companies. It doesn't have to necessarily be robotics or mechatronics, because what you learn as a mechatronic engineer, if you should choose to go that route, is, like I said, design, hardware, software, electrical, so you really can branch out. I saw that the future of manufacturing in America was going to be automated, and I just knew that's where the direction was going. And so I felt like if I want to be in a space that is cutting edge technology that is leading the way, then mechatronics is the place to be, right? Anything right now, anything involving robotics, industrial automation, AI, anything like that, machine learning, machine vision is the future, right? You will not be hurting if you choose one of those options. I'm really glad, Brittany, you brought up biomechanics, because I think that is going to be really, really big in about 5 to 10 years.
Yeah, I think so. I think we have a lot of material advances that are coming about that will have applications to that, really.
Big time. Yeah, big time.
Do others have questions? I can always ask some, but I want to give a chance to our students.
Also, I want to give a shout out to Cody. Hey, Cody.
You guys know each other?
Hey, Aaron, good to see you.
Good to see you.
Congratulations, buddy.
Thank you. Yeah, we've had run-ins.
Aaron and I used to play Nintendo back in the day.
Oh, wow. Online
Way
buddies.
back in the day. So Cody and I actually we went to school since probably what, kindergarten?
Yeah, yes, back in Boulder Creek. Yeah, for sure.
Yeah, man. Yeah, I've known this guy pretty much my whole life. Man, that's been a long time. Nice to see you again. Boy,
Yeah,
Pretty,
likewise.
your class brings together people that I haven't seen in a long time.
It really does. Last time Aaron was on, he saw someone else he knew, right?
Yeah.
It was one of our speakers that you knew, I think.
Yeah, it was, and it was his wife that I knew, because we
Right.
went to Cabrillo together.
Right.
Isa Quintanilla, or I guess it would be.
I think it was Johnny,
McCullough?
right?
Yeah, Johnny McCullough.
Yeah. Yeah. Maybe you could talk about your summer internships. Like, you just mentioned that the Omron has these, and there are other companies that may have them. But how about your experience with the summer internships? I think you had a really good background in that.
Yeah, summer internships are tough. There's a lot of competition out there. That you won't always get something that you really, really want, but just take something, right? Get anything. Kind of going back to how I decided to go into mechatronics, it's really difficult, I find, to know what you want to do in life, right? But it's very easy to know what you don't want to do in life. So a very easy way to find out what you want to do is eliminate everything you don't want to do, right? And internships can help you do that. I thought maybe I'd want to go into manufacturing, machining. And so I worked in a machine shop at Fox Racing Shops in Scotts Valley as a machine tender for my first internship. And then after 3 months of that, I realized I absolutely do not want to do this. Right. So you may not get an internship that you want, but it really help you decide, kind of direct you to where you don't want to go. And the next summer after that, I actually didn't get an internship. I worked at the campus foundry. I was able to get into a production assistant position on campus. At Chico, we have a foundry, and we were doing aluminum production for small business or small job customers. And so I managed that, and I just poured hot aluminum all summer in 105-degree weather. It was actually really, really, really fun. And then the following year, I didn't have an internship or a job at all. I just worked solely on the Baja project. I spent my entire summer designing suspension in Solidworks and manufacturing, so that when we started the semester, we'd have we're ahead of the game, right? So you don't always have to do an internship, but make sure your summer is productive. Take classes, right? Don't wait for the next year to take those classes. Get ahead, especially your what do you call it, your general education, if you can get that out of the way, right? Really helps. That way your hard classes you can just focus on.
And did you start working for Omron right out of Chico? Is that how your job path went?
I did not actually. A lot of my friends put out resumes to 100+ companies. I was not that aggressive or motivated to do so. So we had a senior design fair, kind of your last class is sort of your capstone project at Chico. And so one of the sponsors was a motion controller company, right? And the guy that came up, he actually gave a presentation to our class, did this whole thing on his controllers. And after the class, I was one of only 2 people that went up and thanked him and shook his hand and said, thank you for coming. Thank you for taking time out of your business day to come and show us how to do this. So we stayed in touch. I invited him to our capstone fair. He came up afterwards. He liked what I had done with my project. And we had like immediately following the design fair, we had a little interview, kind of informal interview process. He really liked what I had to say, offered me the position. And for about 6 months, I worked for Contour Motion in Milpitas. And then that was kind of a small company. So I decided that I would like to go somewhere bigger with more engineering support. And Omron, let's see, through Chico, I knew a lady that knew a guy that knew another guy that was hiring at Omron. And so it's all about connections. It's all about networking, right?
Right. Could you compare working at that small company with a large company like Omron, your experience?
Definitely. At the small company, I wore many, many hats. Really kind of had to, was my own boss in a sense. I mean, I had a boss, but it was very autonomous position, right? Very, what do you call it? Very startup, very garage type of business, which can be a lot of fun. Some people will really thrive in that environment. I wanted something with more structure, with more, I like working on a team a lot. And so being a single individual at Contour Motion, doing everything myself was just really kind of banging my head against the wall a lot. And so I decided to switch to a company with a larger team of people. That way you get lost a little bit, you're kind of diluted, but there's so much more support and so much more things to be able to do, not to mention a larger budget to be able to do stuff with. So
yeah,
it's kind of it was a better fit for me, but it won't be for everybody.
There's a question in the chat. Oh, there's a couple. Do you spend much of your time working at home or at a facility? And would that depend on the job position you're in? And then going back to the foundry, was that like a factory or a metal workshop?
So I spend a lot of time in the shop. Last March, when the pandemic first hit, I was home for like 2 months and found that I was really limited to like 50% of my work because I need my hardware available, right? So my team, the system engineering team, we come in every day because we need our hardware. But the software development team, I haven't seen them in a year and a half, almost a year, right? So they work from home. They strictly work from home, right? And which is really nice because one of the guys is out in Texas. He moved to Texas and he works from Texas now. So I think that this whole COVID thing is really going to change the work dynamic, especially for people like software engineers. At Chico, it was more of a metal shop. So there's a class you take at Chico is Engineering 160, it's manufacturing, right? And so it's kind of introductory to manufacturing. You learn how to use manual lathe, manual CNC, you learn how to weld, and you learn how to cast metal. And so it's a very small foundry, but we had one large burner, just enough to, make like 10 parts at a time, then melt more metal, then make 10 more parts. And so it was more like a metal shop than a large foundry, but it really gave me a taste of what it could be and how, just taking something from your head into design, into a finished product is one of the most rewarding things that I can think of a person can do.
Okay. Well, are there any other questions for Aaron before we let him go? Okay. Well, I want to thank you. Oh, go ahead.
So, hey, Aaron, this is Cody again.
Hey, Cody.
I've heard that Chico's a party state, but it sounds like you really enjoyed your time there on an educational level. Would you recommend it to others?
Absolutely, I would 100% recommend it. As I said, it's there's three colleges in the country that are A-BET accredited for mechatronics. Two of them are East Coast, and that's like I think MIT and Carnegie Mellon, and then Chico's the only other one. So not only is Chico can be a party school, especially if you go into the business route. The business guys, those guys party like mad, right? You can stay away from it. It's super easy, right? I didn't party very much at Chico, and I think the engineering crew is really grounded and down to earth, and it's actually giving Chico a better reputation. They're not as much of a party school anymore, but it's also a very inexpensive school. It's one of the cheapest schools that you can go to 4-year, and also has one of the best like areas. It's a really nice area to live in, great for biking. There's a brand new engineering building that just opened up last year, and so I do highly recommend it.
Thanks. Hey, it's good to see you. I put my email in your chat for you if you ever want to get in touch.
Yep, I see that. I'm gonna email you from my Google account.
All right, you take care, buddy.
You too, Cody. Nice to see you.
Thank you so much for joining us, Aaron. It was great to see you and great to hear from you.
Thank you, everybody. You can find me on LinkedIn, or Pretty can give you my information if anybody needs to contact me or wants to contact me outside of class. Feel free.
I think I'll let them find you on LinkedIn because that'll prompt them to also open LinkedIn accounts.
Yes.
Which is very useful. Yeah. But yeah.
It is very useful. I get a couple times a month, I get emails from recruiters saying, hey, do you know anybody that wants a position, or are you interested in a position? And so I don't even have to put out stuff anymore. I'm just getting calls. Hey, I got a new job for you. Oh, no thanks. I'm happy where I am.
But it's nice to know that's out there.
It is.
Absolutely. If you ever want to change. Yeah.
Right. Thank you, everybody. Have a nice day.
Bye, Aaron.
Bye.
Okay. So our next speaker is here. Let's all welcome, and I'm going to try my best, Sitlalik. Sitlalik. Okay, great. Sitlalik is here to speak with you. She's from Chicago. She moved to the Bay Area when she went to college. She went to Santa Clara University and did their 5-year Bachelor of Science, Master of Science program in bioengineering with an emphasis on medical devices. And she currently works as a senior development engineer at Biomedical. Welcome, and we're so excited to have you here. Let me see if I can find you. Oh, there you are. Okay, so we'll put you on speaker view, and then hopefully everyone will see you.
Sure. Yeah. So, so like Preeti said, I'm originally from Chicago. I was born and raised in Chicago. I moved out here to the Bay Area for school. I went to Santa Clara, did my master's in undergrad in bioengineering. And yeah, after graduation, I took a little bit of time off. And then I started working here at Biomechanical, and I've been here for the last a little over 3 years now. So in that time, I've worked on a variety of different projects, from like bioelectronics, so like some implantable kind of pacemaker type devices, and then other like interventional medicine, so a lot of like catheter-based stuff. So here at Biomedical, it's contract manufacturing. So what that means is that we, we'll partner with different, like with a lot of people, but, it might be a really small company who, they're just starting out. They don't really have a facility to, develop their design. So they partner with us, they'll use our resources, we kind of serve as their engineers. We might be partnering with, doctors who, they have this idea, they maybe aren't super familiar with product development. So, they partner with us. That's actually one of my projects. I'm working with a doctor out of Stanford. And then, sometimes we'll partner with really big companies too, who, maybe they want to start a new design. They, for some reason, we have some capability that they would like to take advantage of us. So they, they partner with us. But basically, the short of it is that, I've had the opportunity to work on a lot of different types of products. And I've worked anywhere from the super early kind of, brainstorming a device, like, they might have an idea, we kind of wanted to do this, we don't really know where to start. So I've been able to work from kind of those very early stages all the way through to, getting a product ready to launch to market, getting it ready for production. So that's, kind of in a nutshell, going through the entire kind of from, start to finish of medical device development. Yeah, I don't know if there's a couple of questions that.
Well, I'll prompt you with a few questions, but I also want to let the class do that as well if they have any. But could you give us some examples of some of these products that you've worked on so they have an idea of like what you're talking about?
Sure. Yeah. So I can't talk about some. There's a couple I can't talk about. For one that I can, it's an implantable device that's to help short bowel syndrome. What this is sometimes when babies are born, they have a really short intestine. And this is, if it's less than a third of the length it should be. So when your intestine is that short, your body doesn't have enough, your body isn't able to absorb all the nutrients. And for young babies, a lot of the times this leads to just a cascade of issues. And for these babies who are born with a short bowel, a lot of the times they don't make it past, there's a high mortality rate between 3 and 5 years of age. The treatment is really expensive. And so it's a really hard condition, that these babies are going through, that their families are put through. So one of the devices that I'm working on, it's an implant that gets inserted into their small intestine. And over the course of 1 to 2 weeks, it actually, it applies a force that lengthens that intestine. And then the device, it can either be removed surgically or it can pass naturally. And that's, a procedure that could be done multiple times to help increase the length of the intestine. For some of these babies where, their intestine is really short, a couple centimeters of length already, contributes like significantly to the amount of nutrition they're able to uptake. So, this is one of the examples that's actually probably one of my favorite projects, but it's really cool. It's, I've been working on the implant and the delivery system for that, but there's just like a whole variety of different projects, but that's one that's, I think, is super cool.
Yeah, I want to echo what's been said in the chat. Wow.
Yeah.
That's amazing. And could you talk about like your participation on like the medical side of things? Do you need to know the body? Did you take anatomy? Did you, was that part of, do you get in there and do the surgery as an engineer? Like, tell us about that.
Sure. So yeah, I mean, in undergrad, I definitely took like anatomy and all those fun classes. To be fully honest, a couple years out of college, like I don't remember all the details. I've definitely had, to refresh my memory working on this project, but, for this specific project, I'm actually communicating quite closely with like the doctor and the surgeons and kind of like their medical team. A couple, I guess, months ago at this point, I was actually able to like see them perform one of their like animal case studies. So this was, a device that like we built both the implant and the delivery device. And, you go get them sterilized and it's this whole process, but, I was able to like physically attend the surgery like they had. It was on a pig. So, I'm there, I like, gowned up, I'm in the surgery room and I'm able to like watch this whole surgery. Like, they make the incision. You can see them like pull out the entire intestine, looking for the correct place to. And then they just, they do the whole thing and then they just tuck everything back in. So like, that's a really cool experience. Like to actually like see that. And then, we get to follow up, like, this was successful. It passed after this amount of time. And, they can take like images through like x-rays, radiography, and they can actually see like, this was, they marked it off, this was the original length of the intestine. And, after everything, they have those same markers and you can see that the length of intestine has grown. So that was, that's been a really cool process. I've been working on this project for about 2 years now, and this is one that we started from the very, very beginning. And so, to be able to see it like actually like being used in an operation is really cool. And the goal for this one is to eventually get to first in man. So, get this whole development process, do all our testing to make sure that we have a safe device and that we feel comfortable using this like in a person. So it's pretty cool stuff.
That is really cool. Was there a question from the class? I thought I heard somebody. No, okay. Could you, like this class, Engineering 5, is Introduction to Engineering. So many of the students here have an idea of what field they want to go into, but they may be swayed by what they learn in the class as well to explore something else.
Yeah.
What advice would you give any of these students who want to pursue working in the field that you do?
Yeah. Oh, good question. So for one of the cool things about medical devices is that you don't necessarily have to have a bioengineering degree to work in this field. A lot of my coworkers have a background in mechanical engineering, electrical engineering. Those are pretty common ones too. So if medical devices is something that's interesting to you, you can work on medical devices coming from, a different, from different like approaches almost. And ultimately, a lot of the stuff that you need, you're going to learn on the job. It's definitely important. Like in school, you get a lot of like kind of the foundations. And I'm sure the students have heard this before. Like when you move into the workplace, like it's a different way of learning, and you'll learn a lot of what you need on the spot, like on the job. That being said, I think one thing's really important is, for everybody, students, whoever, when you're starting a job, like you really have to put in the effort to like find resources at work, or, kind of take the initiative to kind of like learn. So it's long story short, you can work on medical devices. There isn't one clear path. You can get to it from many different routes.
Which is great. Yeah, we're talking about the broader field of mechanical engineering. Mm-hmm. Biomedical and biomechanical fall under that, bio as well. So that's great. So I might be, here's a question from a student. So what types of, and this was kind of where I was going. So I'll ask theirs and I'll also throw mine in. What types of materials are used for biomedical devices? So plastic, non-toxic, metals, or how do you coat certain materials so that no toxins, bacteria are developed after the surgeries? And then my question was going to be what you see with the emerging materials, like the ability to 3D print biomaterials, as well as like nanotechnology. How do you see those in the future of this field? That was my question.
Sure. So I'll start with the first question in terms of what materials do you use. So you use a lot of different materials in medical devices. You definitely use plastics. You definitely use metals. There's like specific metals that that are implant safe. There are some that you try to avoid. It's long story short, use a lot of different materials. When you're actually building a device, what you want to look at is, how am I using this? If it's going to be, if it's patient contacting, if it's going to be an implant. If it is an implant, how long is it going to be in the body? Where is it going to be in the body? And based on these different categories, there's different levels of testing that your device has to go through to be, that has to go through and successfully pass to be considered safe. So, for the implant that I was working on, it's going to be in the intestine. It's going to be, touching mucous membrane, the intestine. And it's, we're testing it for, it's considered a permanent implant because it's over 30 days of an implant that we're testing for. But there's like a set of testing. So the implant that I'm working on, it's got metal and it's got plastic. So there's a lot of varieties of materials that you're using in medical devices. And then Pri, for your question sorry, can you repeat it?
Well, I was asking if you had, if you could advise us how materials of the future and nanotechnology are making their way into this field.
Yeah, so in terms of, I frankly don't have too much experience with like 3D printing, like tissue. It's definitely something I learned about in school. I haven't had, the chance to work on that specifically, but in terms of kind of like nanomaterials, and the idea of moving to a really small scale is definitely something that's, happening in the medical device, like in the medical device world. One of the devices that I'm working on, it's, I'm working on it under a microscope. It's basically a pressure sensor, and it's, it's got a diameter of like 4 millimeters. And so when you're working on it, like, you're processing it, these parts are really tiny, you're like doing this different processes, and you have to be really careful because like if you lose this pin that's like 40 thou of an inch long, like it's lost, you're not going to find it again. But even then, like the customer that I'm working on this, they want to make that same device at like a third of the size. So, it's not quite nanoscale, but, medical devices, like we're definitely moving in a direction where we want to get things as little as possible. And then, again, with like human anatomy, like there are, veins and arteries that are, if you're putting a catheter or you're putting a stent, there's parts of the body that are really small, and we have to be able to successfully develop devices that can be inserted to that specific location through, really small arteries, whatever it is. So yeah, I mean, medical devices, small devices are definitely, a way that that the medical device world is moving towards.
That is so cool. Okay, so there's another question in the chat. What's the smallest device you've worked with? Is the pressure sensor something you would normally work with, or is it more rare?
So I think this pressure sensor is the smallest one I've worked with. Is it something I'd work? So with this is kind of the only pressure sensor that I've worked on, and part of that has been just the nature of the company where I work on. We're really working on like a variety of different medical devices. There are other teams here at the company who are doing kind of similar like pressure sensor devices. I don't know the specifics of that, but I mean, yeah, that's there are more than there are a variety of like small pressure sensors that people are trying to develop and like get them really small and stuff. And there's some like pretty cool applications where they're trying to measure like the pressure in like your eyeball and stuff like that, which it's pretty crazy stuff.
Yeah. Was there someone else who had a question? Oh, okay. Is CRISPR technology the next big step in medicine?
Yeah, a little bit out of my wheelhouse there. So yeah, I guess I'll jump to something really quick that Aaron said. I heard him before he left. This might seem out of left field, but I promise I'll bring it back. So one of the things that Aaron said was about internships and how they're kind of hard to get. You kind of have to work with what you've got, and sometimes it helps you find out what you do and do not like. When I was in college, I didn't do an internship. I did research with a professor, and I learned that I didn't like research. So kind of that lab work, the CRISPR stuff, it's not my strong suit, I'll say. So I'm sorry, I don't have a good response to that. Yeah, the kind of the pharma stuff, I'm not as well versed in.
Sure, no problem. That's fine. But maybe, so did you ever do an internship as an undergrad? You did?
Yeah. No, I didn't.
Oh, you
did? I did. Yeah, I did research with a professor on campus. That became my senior design project. And even though that project has nothing to do with what I'm doing now, when I interviewed for this job, I talked about my senior design project and, being able to describe it and like the science behind it and like what I actually did on it. Like I used that senior design project as a vehicle to show my skills and like how I can be successful in like this work environment. And that, that's one good thing that came out of it.
So did you get this job then right out of college? Is that
so? So I took a little bit of time off after school. So I did the 5-year program. And after that, I was kind of like, I was tired. I was a little beat. And I went back home for a couple months, and I was just kind of like laying low, slowly kind of applying to jobs. And then I actually heard through this job through a friend of a friend. So, it's one of those things where Aaron was also saying it's a lot about like networking and who you know and all that stuff. And, this friend reached out to me like, hey, are you still looking for a job? And I was like, yeah, actually I am. And, the connection was made. I had an interview, and then I started like the week after. It moved really quickly. Yeah, so it was a very fast process. So, yeah.
Wow, you really can't deny the power of the network. How did you create your network? And maybe some suggestions on how these students could do the same.
Absolutely. So when you're in college, and I'll say this specifically for medical devices, it's a really small world. You never know when you're going to cross paths with people. This job actually got through one of the other women who worked at my lab when I was doing my senior design project. And, we knew each other. She knew how I worked. We got along, like we had a good working relationship. So, she, had a positive impression of me. So, when she heard about the shop, it's like, hey, I think you could be a good fit. When you're building your network, I think it's really important, like look to your other classmates, because you don't know where your paths are going to be in 2, 5, 10 years. And you never know when you can help somebody else out. And you don't know when one of them can help you out. It's, when you're thinking about building your network, it's not so much about like, oh, being, best friends with like the CEO of this company or whatever. It's honestly, it's like, it's the people right there with you, because, there's so many of you and you probably don't realize how many connections you have. And it's, it's about maintaining, good relations with those people, because truly it's a small world and you really do not know when your paths are going to cross. Yeah.
Great advice. I was sitting here, I was kind of thinking, so are you able to go to work in our current environment? Like, it seems like your job would need you to be at work. It's not something you could do at home. Is that true?
Yeah. Yep. So when the whole pandemic started, we kind of did this like hybrid where we like split the office and like people were allowed to come in every so often. And then, by the summer, a lot of us have to be on site. So I do come into work every day. And working from home, for me, it wouldn't be easy. There's a lot of what I do, I need to be on site. If I'm, working on a build, I want to be there, like making sure that everything's going fine. If we're like developing something, like I have to be there to be like working with the materials. How are we processing this? Like, how are we, what materials are we using? Does it all work together? A lot of the times with these devices, I'm also the person writing, how do you make this device? I have to know how it works. I have to be there. I have to get my hands on it. How does this piece fit with this? Does this piece fit with this? Is this the correct match? All those things. So a lot of my job, I do have to be on site. Working from home would not be too easy for me.
No. And do you do a lot of testing of the things you develop too?
Yeah,
maybe you could talk
absolutely.
a little bit about the testing process. I think that would be interesting.
Yeah. So when you're, developing a device, there's plenty of testing that goes on. So I'll just, more than testing, I think I'll just do a quick overview as to what the product development cycle for a medical device looks like. So, you'll start with a brainstorm. You maybe make a prototype or two of a couple different ideas. You test them to see if you like how they work. Once you have, you've selected your best idea, you'll build a couple more prototypes and, you'll test it. You'll test like, is this functioning the way I want it to test? Is it doing what I wanted to test? Are we, within the restraints of our device? And you also have to, how do I say this? You also have to be able to test how you're testing. Like you have to make sure that the test that you're executing is accurate and that it's going to properly test what you want it to test. You don't want to get a false positive and say like, oh, we passed. And it's like, well, no, your test was faulty. So you go through the cycle of testing and, once you've decided like, okay, we like our test method, it works, and we like how our device is being tested, you go through this whole, it's called DV testing, design verification and validation testing, but you'll build, a large sample of your device. And the sample, by sample, I mean large, like a quantity. You look at the risks in your design, and based off of those risks, you have to make choices, what the sample size you need to test. And then once you have your sample size, you've built all your samples, you do your DV testing, and that's usually kind of your really lengthy process. That includes, the mechanical testing. If it's going to be an implant, you have to do biocompatibility testing. So, there would be, oh man, they might have to do an implant on an animal. It's usually like rabbits, just a whole scope of testing. And, once all that testing is complete, you submit to like the FDA or to whatever body you're kind of testing under. But yeah, there's a ton of testing. I mean, yeah, I'm thinking about one of my, I'm actually doing some tensile testing later today after this call. After lunch, I'm going to go jump and do some more tensile testing. Yeah, no, there's a ton of testing. There's some people who like that's their whole job. They just design and tests, and they, execute tests and they design and all that stuff. But yeah, a ton of testing.
Yeah, as in the class, we talked about the engineering functions, and there are test engineers, there are design engineers, there are manufacturing engineers, and one job can run the gamut of all those, but then there can be jobs that just do that. And it sounds like you get to be involved in a lot of those different aspects.
Yeah, and so part of that is, Aaron, it's funny, Aaron was also talking about this a little bit, but so when I started working here, I was actually the 4th employee, so it was a really small company. Since then, it's grown a lot. We actually got bought out by this giant or much bigger company called Biomedical. And so since then, like we've grown a ton, but having started at such a small company, I, had the opportunity to wear a lot of hats. Like Aaron was saying, I was the R&D engineer, I was the technician, I was the project manager, I was the manufacturing engineer, I was the test engineer. I got to wear all of these hats. So that's been a really good experience, being able to kind of test out all of these different areas. But yeah, I mean, a lot of times in a bigger company, and even now that, this company has grown, we're, kind of being a little bit more, how do I say this? We're not wearing as many hats. We still wear plenty of hats, but not as many. But yeah, no, absolutely. There are definitely like professions that can be dedicated to, one specific and part of the process. Absolutely.
Yeah, and it's kind of fun to wear a lot of hats, but then it's also really fun to do what you're really good at too. So it can be a boon either way.
Yeah.
Well, we've taken a lot of your time. Is there any other questions that anyone in the class has that they would like to ask Sitlalik? I guess not. Well, thank you so much. It was really great to meet you, and I'll talk to you again soon.
Absolutely. Cool. All right. Thanks, everyone. Have a good day.
Thank you. Okay. Wow. Well, those were 2 great speakers. I hope that you guys got a lot from that and got a lot of info, not only about those fields and all the various exciting things you can do within those fields, but also some advice on just the whole internships, the networks, all of that. If you have any questions that come up, I have contact information for both of them. And actually, they're both coming back this afternoon for section 2. So I can also ask your questions and get answers then if something comes to mind. So now what we're going to do is we're going to take a break. We've been together for almost an hour and a half straight. During the break, I'm going to ask you all to collect your materials for the project. And I had put them in the chat earlier. Let me copy that and put it back in the chat for those of you who may not have seen it earlier. So the key here, and I want to just point this out, is that just find at least one item from each group. So this was from the email that went out, but so clay, something with holes like beads, washers, spools, hinges, that's going to be useful. Some sort of string, twine, rubber bands even, thread, dental floss. Something that's sort of plastically, like a glove, like a dishwashing glove, or a like one of those latex gloves, which we may have lying around these days anyways, balloon or fabric or sandpaper. So some of you may go to your garage and find things. Some of you may go to your, I don't know, sewing kit and find things. They're kind of in that realm of things. You want to get some drinking straws, popsicle sticks, cardboard, dowel, everything's listed here, some sort of adhesive, and some tools to cut. And then you want some really lightweight objects like a cotton ball, an empty soda can, or a paper cup, a ping pong ball, like a toilet paper roll, the inside thing, the little cardboard thing, anything like that, even just a sheet of paper. If you have cardboard or card stock or some sort of a thicker paper, that's going to be, it's probably going to be the one thing you want to kind of look for, spend a little time and look for. You're not in a group. These are group things by like find something from group 1, find something from group 2 for your project that you're going to work on. So I'll put you in breakout rooms after the break, and then you'll work with other people in the class to do the project. But again, you're doing it on your own as well, and there'll be a discussion post follow-up for that. Any questions before we go to break on just collecting these materials? Okay, so let's, let me see what time it is. It's 2:28. Let's break, or 12:28. Let's break till 1:45. So that gives you a little over 15 minutes to grab everything. Oh, wait, 12:45. And then we'll come back together and we'll talk a little more, and then we'll work on the project. It'll be really fun. All right? Okay, I'm going to resume recording. Hopefully you all had a chance to get the materials. I've made the breakout rooms, but before we start on that, this week, Joanne and I decided that we would be introducing your next project. So as you know, you're working on your interview and engineer project, and by the end of the semester, you will present a little tidbit of what you learned during your interview engineer project. The other project that we have for you this semester is called the Mobile project. So I'm going to share my screen and go over that briefly with you. And of course, you know, you can ask questions all along from now until the end of the semester on this, but this will be due the last day of class. And you're looking at it now in the module, and this page has been published. And basically, you're going to construct a mobile that has items that represent you and your interests. So you can pick anything you want and hang it on this mobile. And the key with the mobile is that you have to have 4 horizontal supports. So if you look in this inspirational one up at the top here, this is a horizontal support, this long orange bar. And then there's another one right under it, and another one, and another one, and another one. So that's 5. And then next to it is another series of the mobile. I think it might be attached to the orange one, and it's also being supported. So you have to have 4 horizontal supports. That means you can hang 4 things, you can hang 8 things, you can hang 6 things, you know, that's up to you. And it's only a minimum. You can have more horizontal supports than 4, no problem. But the thing about it is that no single one of those horizontal supports can be supported at its midpoint. So you need to support them somewhere other than the midpoint. So if you imagine a string holding one of the horizontal cross members, that string cannot be in the center. It has to be to the left or to the right of center. And then when it says the entire mobile must be supported by one string, that's up here, this string that it would hang from. You're just hanging it from one string at the top. And then the key in this is you're getting a little bit of engineering by creating balance in your mobile. So you have to think about what you hang, where you hang it to create a balanced mobile. We don't want it to just flop over to one side. So the description is here, and it says, you know, pick anything you want. Here's some engineering examples and stuff. And then you'll create a document and present your mobile. And so the document will have a title page that has your name and date, photos of your mobile, discussion of the importance of the items you've included, and a drawing. And this is your also a little introduction to engineering drawing, where you can draw your mobile in a very idealized version of it. And I think we have an example here, and let me hope that it'll download and then I'll open it. But basically it's a 2D sketch of your horizontal members, and you'll show that they're not being supported in the middle. Let me see if I open this file, if it continues to share. Wonderful, it does. Okay, and here's an example. So you can see that here's a string coming down that holds this member, and off of it, 2 things are hung, and each one of the parts has a number in a circle with a leader line. And this is an introduction to engineering drawing. This is how we do engineering drawings, actually, is we have part numbers and circles with leader lines. And, you know, this horizontal member, this one, and this one, and this one, they're all four different in this particular example. They're different lengths. They may be different materials. But if you use four identical skewers, as an example, then each one of these pieces would have the same number in it. It's part number one, which is a skewer, and you need four of them. So depending on your particular mobile, it will have its own drawing, very specific to you. And you can see here, this is the string that holds the whole thing up. And you will also create a parts list down at the bottom, and it just has the number and a listing of what it is. So we know. And your drawing here can be, you know, a little block and with a number, with the leader line and a number in a circle. And then it could be, you know, a set of keys. You don't have to draw, you know, your objects in great detail. We're not expecting works of art here. It's just a little exercise to help you get started in visualizing and trying an engineering drawing. If you happen to know CAD, you're welcome to do it in a CADing program, or you're welcome to put together a pencil sketch. Either one works. And it'll be a page in that report that you submit, which I think I'm going to go back to here. So it says here exactly what to do. You have the example to work off of. And then there are some resources that may be interesting to you. And one of the things is this video. I'm not going to show it now in the interest of time, but please go and watch it. And it shows this particular mobile over time lapse and just the movement of it. And it's so eloquent and just so there's something about it that's super serene. I'm having a hard time putting into words, so watch the video and come up with your own words for that. But it's really a cool video on that. And then there's some other web resources related to mobiles. So again, like I said, it's due the last day of class at April 15th at 11:10 a.m. And you will show everyone your mobile on that last day as well. Are there any questions on the project? Okay, so this is a semester-long project with the mobile, or half semester, and you're doing your interview one. Those are your only two projects for the semester. So, you know, and then now you just have your homework assignments and quizzes and our weekly in-class projects. So that's a little different than the weekly in-class projects are like your participation in the class, whereas this is a project where you have an official submittal. Okay. All right, so then let me now introduce our in-class project for the day. And if you have any questions on the mobile that come up later, feel free to ask, no problem. You know, and just so you all know, I see you today, and now I will see you again in 4 weeks. So you'll be hearing from Joanne and Carl over the next 3 weeks, and then I will see you on the last day of class. But if you have questions related to the mobile project, email me anytime over the next several weeks. No problem, okay? And I will answer those for you. And if it's a big question that I think the whole class can benefit from the answer, I'll just send out an announcement to everybody, you know. But if it's something specific to you, like, oh, can I put this on? You know, I can answer those as well. Okay, so now let's talk about today's project. So today you heard about mechanical engineering and you heard about biomedical engineering. And so we're going to combine both of those. And today's project is going to be making a mechanical hand that can pick up things. And this is a really fun project. And I'm going to share my screen in a minute. I clicked on the wrong thing. And what I wanted to say was, I have found that the class time may not be enough to finish your project, but do your best during the hours of the class that we have, and then you can always finish it up later. We will come together towards the end of class and look at, you know, what progress has been made and share some of our ideas with each other. You all have different materials, and you're going to try and build something that can pick things up. And so this is kind of along the lines of the prosthetics I was talking about, but you can also think of it as a robot hand, picking something up. So I have this page, which is published and available to you, and it's got an inspirational video here of a hand that was made by an 8-year-old girl. Sorry, she wasn't made by her, but an 8-year-old girl has this hand and how important it was to her. So you can take, it's only a couple of minutes. You can take a couple minutes to look at that. Some background information. Here's the materials, and I had made these into groups, so you can see some of the things. Like group 1 was these items here, which would be really nice as joints. Think about your fingers. Okay, you're creating something where you can manipulate it to move like your fingers to pick something up. Okay, and so I've changed the word group into things for ideas, and by no means are you locked into these ideas. You can do whatever you want. The idea is to have fun and try to apply some principles of these two fields to a fun project. So I've got that there. I know it says 1.5 hours, but I don't think we have 1.5 hours left in the class. No, we have an hour and 15 minutes left in the class. So we're going to have a little less time to work on it than we would hope, which means that you should take a little time after class and finish up your project. So, read through these questions. What will it do? Think about what you want to pick up. Believe it or not, you can tailor your mechanical hand to only pick up things that are rectangular in nature, or only pick up cylindrical things. You can do that, or you can make a hand that can pick up a variety of things. You decide what you want to do. This is your project. Think about your fingers. You can have 5 fingers on your hand, or what other combination of fingers could you have on your mechanical hand that would pick things up? Up to you. So these are questions that I've put there. And then you can start to put your hand together with your materials. And, I've placed this order here of kind of the engineering design process that we talked about, trying to sketch some ideas out and things like that. I hope you'll follow it, but you don't have to. You can go with the flow of how you feel. So then you'll test your hand, and this is really where the fun comes in, is we'll see what you guys can pick up. And hopefully before the end of class, we'll be able to see some great examples of just at least one thing you can pick up. Let me give you one hint. Do not try as your goal to pick up a little bit larger things than smaller things. Smaller things are very hard to pick up. Just you put a paperclip down on the desk and try to pick that up with your fingers, and you'll notice that what you want to do is slide it over to the edge, and then you can pick it up. So think about that when you're designing your hand and picking items to try to pick up. The smaller things are going to be a little bit harder than the larger things, just as a word of advice. So are there any questions on this project? And then as you're thinking of those questions, there's a follow-on discussion for this class. I asked you to list one thing you learned from each of our speakers, and also to answer a bunch of questions about your hand, post a photo, possibly post a video picking something up so that everyone can see what you've done and what you would do differently and things like that. So that's also been published, so you can look at that discussion. And all of that is due, Monday? Monday. Okay, any questions?
I have a question.
Yeah.
I see that the materials list is kind of very flexible.
Yeah.
Is there, if we find something that we're like, oh, it'd be cool if we could incorporate like a pipe or like a tube or like some type of other material that's not on the materials list, is that something that is, within what
Yes.
we do, or do we want to like restrict to like?
No, I want you to use whatever you want to use in your house. If we were all in the classroom together, we would give you a set of materials and say, use this. But we're all at home. Use whatever you have in front of you. If you don't have the things on this list, no big deal. These were just ideas. It was kind of like things that you could think about,
Cool, that's good to know. Thanks.
Okay. Yeah, great question. Other questions? Okay. I do have one student who's not at home and can't work on any materials because they're not with any materials. So to that person, I said, look, give your ideas, get ideas from others, think about the materials you have at home that once you get home, you can do the project. So if you find yourself in that boat as well, where you don't have materials with you, then, you know, again, you're in a team dynamic, and your contribution to the team is going to be, hey, try this, you know, or do some research, or and think about your own project. Everybody does have to create their own hand to submit on the discussion board. So if you can't do it today, you'll just have to do it at another time between now and when it's due. All right, so we're going to go into our breakout rooms. I just want to make sure that I just want to make sure that I have all the breakout rooms right, but apparently, yeah.
Just for clarification, we're going to just sort of brainstorm with each other in the group, then we're going to go in our own separate ways and work on our own projects. Is that correct?
Yeah, and you know, you can say, hey, this isn't working for me. What are you guys using? Oh, I have that. Let me try that. You know, yeah, you're all doing your own project, but you're kind of helping each other out in that. Yeah.
Cool,
and if you have questions, come back and ask me. I will be here, or ask me to come to your room, and I will come to rooms. But you know, if I get a lot of requests, you just have to be patient, and I'll visit your rooms. All right. It looks like we have 3 people per room. And actually, the student I was talking about, I don't have in the, oh, no. Yeah, I don't see that student in the class anymore. So I guess maybe they took a break. Okay. So, yeah. So, you know, I've set up the rooms for 45 minutes. I think, yeah, we'll come back when there's about 10 minutes left in class and just share really quickly what we have. Okay. So good, great work. Thank you for everyone who shared. Those of you I know who weren't able to share, you're probably still working on your projects. I'm really looking forward to seeing your posts on the discussion board, and where possible, if you can show a video of your hand picking something up, that would be really great. So I've made it optional to post that video, but I'd love to see as many videos as possible. We're only talking about like a 15-second video. That'd be really fun. I think it'd be really fun for others to see too, your hand in motion, and see, you know, again, we broke up into little groups. We all had these little ideas. You can consider that the brainstorming part of the engineering design process, and then you all came up with these little prototypes. Of course, if we could all see everybody's, we could find the best solution possible, kind of like what Lalit was talking about, to find the best solution and then build one big class prototype. That would be really cool. So great work. I introduced to you the mobile project. If you have any questions on that, do not email Joanne, do not email Carl, email me directly, and I will answer those questions about that project. Next week, just letting you know ahead of time, there's not going to be any prep. You're going to meet with Carl. The topic is electrical engineering, computer and software engineering. And I think he's got a project during the class as well, but you won't need to bring, there's no pre-class gather materials or prep or anything like that for that. There's a homework, there's a quiz, and those are due Monday. Those are on chapter 5 of your book. And of course, our discussion for this class based on just wrapping up what you did in the class today and what you got from it. And that's due Monday as well. So great to see you all. I will see you now again on the last day of class. So I wish you the rest of your 3 classes go really well. And feel free to get in touch with me if you have any questions on this project or the mobile project. Okay.
Thank you, Preeti.
Thank you. Nice to see you all. Thank you so
Bye.
much. Bye-bye.